There'll be no amplification sound, so it's just a recording.
That's okay.
Okay, so I get no feedback. That's on, is it? Right, okay. Okay, hi there, my name's Simon Riggs, as we just said, and I've been told to speak loudly, so I'm going to speak loudly about PostgreSQL, also known as Postgres. Full disclosure, I haven't got any devices attached to me apart from the microphone, so no hidden Raspberry Pis or anything like that. I'm going to be talking about databases for the Internet of Things, specifically Postgres. I'm one of the people that like Postgres, so please shout out abuse if you really don't like what you hear. So who's heard of Postgres? Show of hands, please. Okay, keep your hands up if you know something about Postgres. Okay, oh, that's good. Okay, you want to teach me. So Postgres is an open source database. Come on in, don't worry. It's an open source database with BSD style license. A lot of people think that it's a relational database. People that don't like it tend to call it a relational database because they feel that that somehow limits it and makes it 20 years old, as I've heard it said. So Postgres is actually an object relational database, which makes it highly extensible. And what that's given us over the years is the easy ability to add new data types, add new types of index, and specifically some of the things I'm going to be talking to you about today is our ability, fairly recent, to store JSON data within the database in a compressed and yet indexable form, and that's known as JSONB, as well as our ability to store GIS data within the database, which is via a package called PostGIS. So what I was asked to do was do a demo. So I'm going to do a demo just on my laptop. And what I wanted to do is just give you a very simple database to think about. It's a single table, and it's got two columns in it, one called TS, which is a timestamp, and another column called J, which is of type JSONB. And into that simple table, I've got a pretty simple blob of JSON, which has got a field called device, which has got a number, and then 12 things that I'm calling measures, but obviously they could be temperature or position or air pressure or anything you wanted that to be. So the JSON that I'm storing, the schema doesn't matter, this is just a demo. The number of fields in the JSON blob doesn't matter. That's just a demo as well. Okay, so just giving you a flavour of what's possible. And on that table, I'm adding a single index, and I'm going to be using a new type of index that we have in Postgres 9.5 called a block range index or a BRIN index. And this is a type of index that's specifically designed to be low overhead as you insert data into it, and it's also specifically designed to have a very low overhead as the table grows. So it is specifically designed for tables of like terabytes and above size, and what I'm here to tell you about is really that that's specifically for the Internet of Things. So this is the bit where I wish I'd clicked my mic on, so we'll attempt to do that here. If you let me know if there's a problem with the audio. So what I've done here is just set up a simple database. As you can see, I've got a single table in the database, as I've just described. The current table has got 2.2 million rows in it, and that is 430 megabytes. So rather than do anything attaching to the internet, I'm just going to give you a demo just straight off my laptop. Okay. So if we truncate that down to 0 bytes in size, what I'm now going to do is run a test where I actually load data directly into that database, single records at a time, just so that you get a flavour of roughly how fast Postgres is. So I'm loading 100,000 records using 2 connected sessions through to the database, and each individual session is inserted into the database. So it's transactionally recording each and every individual insert. So in this particular example, I've got 11.7, nearly 12,000 transactions per second going into the database on my laptop. Okay, and that's using fully safe, fully sound transactional semantics. Okay, if you don't want that, if you think that that kind of thing is over the top, then we can do it a slightly different way. What I've got here is the ability to use relaxed transaction semantics using a feature called synchronous commit equals off. What this does is it doesn't flush the transaction to disk when you commit, it just leaves it in memory, and it's then flushed half a second later. So if you're willing to potentially lose some data in the event of a crash, we can greatly increase the performance from the server. Okay, so by enabling this feature, I get 32,000 transactions per second off of 2 sessions. Okay, so as we can see, we're getting 30,000 transactions per second using full individual transactional semantics. What I can also do is I can actually load data into the server using bulk mechanisms, and previously I've prepared a data set that's got 2.2 million rows in it, and if I load that into the server, you'll see that that loads significantly faster than the individual row mechanisms, and hopefully that's going to come back about now. Of course thought transfer. So 14 seconds, 2.2 million rows loaded, and that means it's loading 1 million records every 6 seconds, okay, into the database. So why show you 2 things? Well, obviously, if you want to just load the database with full transactional semantics, that works. If you want to accumulate records into batches before loading, that is an even faster approach. Both of those are still transactionally sound, so you can still query the database while that's happening. Okay, so people can still be accessing their application all the while you're doing this. It doesn't put any form of table lock on the system. All that we require is that you cannot access data until it's been transactionally committed. Once it's committed, everybody can see it. Okay. So back to the details. So I've been loading JSON blobs. What I was doing, actually, the program that did that was actually randomly generating the JSON blob, and then inserting that. So it wasn't predefined data. It was actually calculating that and loading that as part of that demo. So let's just have a look at the numbers that we looked at. That's 30,000 JSON messages per second, which works out to be 10 million messages per hour on my laptop. Okay, so if we had a bigger server with greater capability, you can imagine what you'd be able to do with that. The bulk data load was 1 million JSON objects loaded in 6 seconds, which gives you 36 billion messages per hour loaded into my laptop. Okay, so imagine what you'd be able to do with a server. What I'm going to talk about in a minute is the fact that We also have Postgres clustering with a technology called Stgresql, and we've got basically linear performance for that. So what we'll be able to do is...
I think your calculations are off a little bit there.
Okay.
I think it's 36 million per hour, not billion.
Okay, that's a shame. Are you sure about that?
Yeah, it's 4 times faster, right?
No.
It's 1 million in 6 seconds, 120,000 per second. Am I wrong?
Okay. It's lost.
We're all geeks here.
Yeah, you did the math while I did the presentation.
No, it's billion.
I think I'm right. So where does all this come from? We ran a project recently called Axel. It was an EU-funded project, so almost all of you sitting in the room have been paying your taxes, I hope, and that's actually gone towards funding Postgres for big data. What did we put into Postgres as a result of this project? Well, Brin indexes, which I've just described. We've also put row-level security into the database, which is of sufficient grade that you can have very complex medical privacy rules inside the database. So, for example, what we'd be able to do there is have devices that load things like blood sugar measurements and blood pressure and heart rate sensors loading data into a system that nobody but you or your doctor or somebody that your doctor had temporarily authorized would be allowed to see those readings. Okay, so one of the types of applications I hope we'll be able to do with open source software within 10 years is that you'll be sitting there stressing about something and you'll hear an ambulance coming towards you and you'll go, that's strange, what's the ambulance for? And it will actually be a sensor on you that's detected that your blood pressure and heart rates have risen badly as a result of your stress, and they've predicted that you're going to have a stroke, and so they've sent an ambulance to come and get you before you've even realised it's happening. So that's the kind of thing that we'll be able to do with the transaction rates that I'm talking about. So we'll be able to take a blood pressure or glucose level reading from everybody in Europe every minute. That's the type of numbers that we're talking about here. So what have we got in terms of Postgres clustering? The idea is that we're going to have a database that is a single system image, but it's composed of many separate data nodes. This is just about to be released as beta. We've benchmarked it using the industry standard TPCH benchmark, which is a complex decision support benchmark, not necessarily related to the Internet of Things. And the red lines are the performance of Stgresql. The upshot of that is on a 16 node cluster, we got quite a few of those queries going 16 times faster. Okay? The more complex queries, in some cases the performance dropped to like 4 or 8 times, but overall we've got some very good performance. But the most important thing is that for simple queries we've demonstrated linear performance gains or linear scalability. So if you can imagine the type of things we'd be able to do if you had a 128 node cluster, you'll be able to scale that up significantly. And there's some other graphs that show measurements of linear scalability. So the blue line is Postgres, and then the lines above it are 2, 4 and 8 node performance, and you can see it's scaling upwards very nicely. We've done that test at 16 nodes at the moment, and we think there's no particular reason why we can't go to 32 and 64, but you know, we're just sort of working our way up at the moment. One of the other things that we have recently released is a tool called PGLogical, and what this is a publish and subscribe data transport extension for Postgres. And the idea here is that you'll be able to connect databases together into distributed data architectures. So, for example, you'll be able to have devices feeding into a regional center, and then regional centers feeding into area level centers, up to potentially central data warehouses, with a model that we'd be able to send reference data down to the individual devices, and then collect detailed data and send that back up the chain the other direction. Okay, so a replication in multiple different directions. But here we're sending specifically the individual data items. We're not sending things like changes to the index or vacuum records and things like that. Don't get sent via this mechanism. The PGLogical stuff all works cross-version now. So one of the things that I think will be possible in future is you'll be able to install Postgres on your individual devices, and those devices won't need to be upgraded for 10 years, but it will still be able to send data back through a distributed data architecture like this to a central server, where the central servers we're actually upgrading each year as the software improves. Okay, so that's one of the design objectives there. This was 25 minutes, and I wanted to say everything I wanted to say fairly quickly so there'd be some time for questions. So I've got about 6 minutes left. What I'd like to do is just summarise some of the things I've told you about Postgres. So look, most importantly, the model you use for your data is flexible. You can use a schemaless design if you choose, or you can use a relational model, or a mixture of the two, and there's other ways of doing things as well. So we support a number of different data types. That's sort of flat structured data, but we also support document style, text style data, or GIS data as well. Hopefully I've demonstrated that the data loading rates are easily sufficient for you to consider using Postgres for your applications. Although I didn't give a demonstration of the performance of it, the Brin style indexes, I would remind you that the Brin index was in place while I loaded that data. Okay, so you could see how little the Brin index slowed down the data load. But the Brin index itself acts very similarly to partitioning, in that it will allow you to access date ranges in that table with high performance. So that's what it's specifically designed to do. Also being announced is PostgreSQL. That's going to be announced in the next week or so. I've also showed you, or at least discussed, the fact that we've got low-level security if you need it, and we've also got integrated data transport facilities to create not just a single server, but a whole distributed data architecture that is appropriate for the Internet of Things. A last point is that many people like Postgres because the BSD style license means you've got the capability to install it on devices and not worry too much that somebody's going to be chasing you with some copyright infringement or some sort of babble about GPL or whatever. So it's particularly suitable for embedded devices as well as big data. So that's Postgres. I hope I've given you a good flavour of that specifically for the Internet of Things. So over to questions. Who's got a question? Hello, John.
You have to bring the microphone to the...
I'm sorry.
You have to walk to the person who.
Okay.
I'll walk to you, thanks.
How are you?
How are you? Not very well, thank you. Your demo, SSD or Platinum?
It's an SSD, so luckily enough I can afford one now after years of not.
So I just checked your figures again. So you can do 100 million per hour with USB and 600 million per hour with convection.
Okay, that's good. I'll check those figures myself as well. So, anybody else? Sorry.
So if I can put JSON data in a column,
Yes.
can I also index by a field in the JSON data?
So the question is, can we index the individual JSON items? And the answer is definitely yes. We've got index types that allow you to index particular elements of the JSON blob, and you can have different index types on each of the individual items if you wish. We can just, in fact, index the whole blob, so you've got a kind of everything index approach. So we do that using an index type called GIN, which stands for Generalized Inverted Index, which is essentially the same type of index that Elasticsearch and Google uses. Other questions, please?
So it basically means that
Sorry.
The microphone, please.
How did you do that? So go ahead.
Sorry. So basically it means that your stimulus is also added to the JSON. So you can change the JSON.
Absolutely correct, yes.
So one question is, you always recommend to go through intermediate software that tools to the database, or can the IoT devices, the chips, should they talk directly to the Postgres server
Well, I'm a database guy. As long as you put it in Postgres, I don't mind how it gets there. You know, there's a lot of other considerations that you need to think about. In some cases, it's possible to go direct. Some cases, not. I think. So.
Do you know about libraries for small devices that allow you to connect directly to Postgres?
Well, obviously, we just use the Postgres client libraries for that. So, but they're available from a number of different languages. There's language bindings for basically everything.
I do have a question.
So that wasn't supposed to be evasive. It's a capability of Postgres that you can access it anywhere from anything. So, yeah.
Can you come with the microphone?
Yep.
One of my previous job, I did a lot of CouchDB,
Okay.
which is all JSON all over the place.
Sure.
And the previous job, I did 4 years of Postgres,
Cool.
Postgres SQL. So I was wondering, with your knowledge of Postgres, and maybe your knowledge, I don't know if you do have of CouchDB. CouchDB is everything is JSON, and it's optimized for JSON. So I was wondering if you could do a parallel with advantages and disadvantages of
Well, obviously, I have an opinion on CouchDB, and I prefer Postgres. So what I can tell you, I think a direct comparison I think would be unfair in many ways. What I can tell you with Postgres is that it's a database platform that contains many different elements. So we are innovating and progressing the Postgres technology very rapidly in a number of different areas, and all of the areas of progress all interlock and react. So the types of things that you're getting there, enhanced security, enhanced indexing, new data types, all come together in Postgres, and that's why I work on it and why I recommend it, because if you design your own data store, you're basically losing all of the momentum and all of the additional features that you get with the Postgres package. So Postgres may not always be the first to innovate in use of new features like a new data type like JSON, but we do innovate in many areas. So the PostGIS implementation, for example, is widely acknowledged to be the best in the world, and obviously things like transactional semantics, robustness, as well as performance is what Postgres is noted for. So I don't want to kind of diss other projects, just want to point out that Postgres has got a lot of momentum and a lot of focus with lots of different features coming together in one place. Any other questions? Hi.
Is Green Index specific for the data context, like duration and time, or also for the other types?
So Brin indexes can be used with any data type. They're specifically designed for use with naturally ordered things. So the example of date time there is useful because the data has a natural ordering. So another example of something that you might want to use would be a sort of order ID, which would naturally increment over time. That's for its best use case. If the data's sort of all over the place, then it is much harder to use that style of index. So this Postgres has got 6 different types of index, all suited for different use cases. So whether it's sort of B-tree is useful for OLTP, high volatility, inserts, updates, deletes, or Brin is more suitable for historical tables, and we've also got text style indexes as well of various kinds. Yeah. Hi.
What are the enhancements? I have seen you have a lot of enhancement on parallel processing, something like parallel functions, and using more than one CPU for process. What is the progress of this features?
So the progress that we're making on parallel queries, that we're developing intra-node parallel query, which means you'll be able to scale it to the number of CPUs within a particular node. The technology I'm presenting here with Postgres XL allows you to scale across multiple nodes, so that you can actually get a much higher degree of parallelism using XL than you can with the intra-node parallel query. The parallel query that we've got doesn't cover all types of query, so the Postgres 9.6 version that will be out later this year, maybe September if we're lucky, will contain the first elements of intra-node parallel query.
Okay, Simon, thank you very much. That's all the time we have.
Bye.